Hello, everyone. I'm Kamal Bhatt, working as a software product manager at STORDIS. Today, I'm going to speak about two open source projects initiated by STORDIS. One is Monsoon and another is ORCA. Monsoon, on the one hand, is focused towards the monitoring needs of the SONiC switches, and ORCA, on the other hand, focuses on the configuration and orchestration part of the SONiC switches. And when I say SONiC, we are testing our solutions majorly on the Broadcom enterprise version of SONiC. So let's have a look into first Monsoon. That is a monitoring solution. So Monsoon brings in together a couple of more open sources, which are Grafana and Prometheus. Grafana, for those who have never used it, Grafana is basically a data visualization tool where you can define your custom dashboards to view the charts and several other visualization formats. So Grafana needs data from somewhere. So Grafana uses data sources. One of them is Prometheus. So Prometheus is a time series database which maintains a database in a predefined frequency that has been configured for Prometheus. So it keeps on collecting data from where? So it collects data from its exporters. Prometheus in its community has a huge number of exporters already available, supplying different kind of metrics. For example, if you have a look on the right side of the diagram, we are mentioning here a node exporter, which is quite a popular exporter already. And it is very useful when it comes to the system resource monitoring. But as of today, there doesn't exist anything which helps you monitoring the networking aspects, the SONiC metrics especially. So here comes the software part, SONiC exporter, which we have developed as a part of this Monsoon monitoring solution. It's an open source solution. So as you see in the diagram, all of these exporters can run in the Docker containers. So the SONiC exporter as well. So SONiC exporter collects all the metrics directly from the Redis database. And for some of the metrics, it also collects or executes CLI commands. If you know, there are some CLI commands on the SONiC where you just supply --JSON and you are having a quite nicely formatted JSON. And that is very easy to be programmatically consumed. In our GitHub repository of Monsoon, you can also find the link for this live demo. That's not really hard to remember. monsoon.stordis.com, port is 8080. And you can try it yourselves, what all metrics are supported as of today. So just to name a few SONiC system information, you can always get platform metrics like fan speed, different temperatures coming from different sensors available on the devices that you can monitor, MC lag, NTP, and list goes on and on. So please feel free. And this is a view-only dashboard. And yes, in the repository, you can also find a predefined dashboard XML. So that I think we have lots of metrics already defined in SONiC exporter. So you need not to define or customize a new dashboard. You can directly import that XML into Grafana and you are good to go. On the top of it, yes, you are free to make any changes as you wish to. So as you would have already realized that there is a shortcoming to the solution, and that is an overhead. That is, every user will have to install an additional software body on their switches. These are exporters. The question is why a user need to install it. We are having already a very robust management framework running, which provides you REST-conf APIs or GNMI calls. You can get almost all the data, and it has matured over the time quite nicely. I believe as of today, whatever SONiC exporter, in addition to node exporter, is able to supply the metrics, this alone management framework can supply all those. So if we rely only upon this management framework that is running in a separate Docker container on the switch, by the way, so we tend to make Monsoon agent free. So you never need to install anything on the switch at the end, and you are good to go. So to achieve this solution, we are planning and discussing if we can replace Prometheus, for example, with Telegraph. Telegraph is a data collector tool, and it has got some southbound input plugins. For example, GNMI, we can rely upon this thing. So GNMI subscriptions, we can subscribe to certain open config paths, and whenever it changes, depending upon the type of subscription you have chosen, for example, polling or on-change events. So you directly receive the notification from the device. It is totally opposite to the approach of polling and asking a device, okay, what is the status now? So that is on the roadmap. This is being worked upon. So the next project, the ORCA. So ORCA focuses more towards orchestration and the configuration of the SONiC devices. This is again also an open source solution. It has got three major components, as you can see. At the very bottom layer, in the blue rectangle, this is called ORCA Network Library. So you can consider it to be the brain of whole software stack. This is a Python package and published on pip.org. It can be installed very easily using pip install command. Now what it does, it uses the GNMI interface of the switches to make CRUD operations, to make any kind of read, update, deletion on the devices. So you can consider it to be a GNMI client, but it's more than that. It not only makes the operations on the devices, it maintains a graph database as well. That is Neo4j. So you always have a real-time information in the graphical format, and in the graph database, you can always have a topology-like view of your whole network. And how we are achieving this real-time updates into the database, that is done again via GNMI subscriptions. So we are subscribing to certain open config paths, and whenever, again, depending on your type of subscription you have chosen, if it is on change, for example, if our interface is up or down, it makes sense to make a subscription with a type of on change. So whenever if goes down, you are interested to get a notification. So such subscriptions ORCA Network Library makes, and it helps to maintain a real-time database. On the top of it, it's a Python Django-based backend implementation, you can say, and it barely provides the ORCA Network Library APIs and wraps it into the REST endpoints. So these REST endpoints then can be consumed by any other application. For example, here on the top of the stack, you see this green rectangle. This is a UI developed in React, and the React uses the REST endpoints, which has been exposed by this Django. So in the Django, you see several other boxes. I mean, I'm not going to go deep into the Django technology, but in the Django, you can develop several other applications. For example, we have user authentication developed out here. And on the very right side, you can see this green box. This is ORCA. This is quite interesting. We are going to have a look into it. This is AI-enabled chatbot, actually. So we will have a live demo of the working of ORCA as well in a moment. So this is a top-level architecture and details about ORCA. And further, what ORCA is capable of doing as of today, it can discover and configure several networking features in your device. It can discover interfaces. It can discover LLDP links. It can configure port groups and discover them as well, port channels, MCLAG, with the links as well. Also, BGP with its neighborhood relationship. That relationship you will see in the Neo4j graph database that's being created. We can have a look into the Neo4j database as well in a moment. Of course, the VLAN discovery and configuration is also possible. So not all of these configurations are currently possible via UI. I will give you a demo about it, but majority of these things are possible via APIs present either in the Django backend or in ORCA Network Library. So as you see, it's a very modular design. You never need to use the full stack at the end. If you are having a Python application already running, you just use the very bottom layer. That is the blue one, ORCA Network Library, pip install, and boom, you are good to go. Just start using the APIs into your application. On the other end, you can choose Django if you want to really consume the REST endpoints. So let's speak about ORCASC actually, which I was mentioning. This is a zoomed in view of this ORCASC application that is running inside this Django backend server. So what it does is, on the UI, we have given a chat-like interface for the user, where in a natural language you can write, for example, get me the list of all port channels on device 10.10.10.10. So currently we are using OpenAI's GPT 3.5 Turbo LLM to process this natural language into what? Into the API calls of ORCA network library. So OpenAI models have this functionality where you can take input in the natural language and ask model to call the respective APIs. So this is how we have trained so far our OpenAI model. So as I have given you example, for example, add member Ethernet 0 to VLAN 3 of device XYZ. So it searches the ORCA network library APIs, okay, which is responsible for configuration of the VLANs, especially the VLAN members. It retrieves the information. Okay, this is a member Ethernet 0 it is speaking about. It will pass them as a parameter and it will get the things done. So we are using LangChain. LangChain is nothing but a Python package which lets you use multiple LLMs. Although OpenAI comes with its own Python package and API, you can directly use it. But then you are very much bound to use OpenAI. We are using LangChain here. Now with whole this solution is still have some problem, I mean, security-wise. OpenAI models, you cannot host locally. So any query, any information, any configuration you want to do, you will have to send it to cloud. And this is a security concern. Why should I tell anybody that I am going to do this in my network at the end? And the problem with OpenAI models is, as I said, you cannot host them locally. So what is the solution? So we'll have to look for some other LLMs which have the function calling capability and can be hosted locally in your premise as well. Of course, you will have to have more advanced hardware with more GPUs and everything. But I mean, people would do that rather compromising the security aspect. So, but this thing, the Llama, for example, Llama as an LLM is having this function calling capabilities. So that thing we are actually currently working upon. So, I mean, if I can quickly show you, any questions? Okay. What is there? So this is our new 4J database that has discovered. First, have a look into ORCA. This is a very basic interface. ORCASC, we will have a look. So I have a GNS3 topology created. I have discovered them. Discovery is happening using LLDP and a seeding method. For example, if you have a device in your network and that is connected to other devices, and every other device is physically connected, and all of them have their LLDP table populated. So you just need to give a single IP of a device, and the algorithm recursively goes on every device and it discovers everything, the full network basically. So I had just one spine, two leaf kind of topology created in GNS3. I have discovered it. So here is an option to discover the device. And further, if you click on details, device info, interfaces, you can do basic configuration from here. Port channels discovery has happened. MC lag discovery configuration is not supported on the UI only, but the backend API is available. That is for the UI support, we are working on it. Port groups at the max, you can change the speed only. Similarly, VLAN, add VLAN, delete VLAN. I mean, these operations you can perform from here. And all goes via GNMI on the device. So still, you need to click a lot here and there. So here comes into the picture, ORCASC. At the very basic, I mean, if you say hi, it's very much like ChatGPT. Nothing else. Whereas OCP 2024 is happening, it will tell you. But as soon as you start giving it like things, get VLANs of device 10.10.229.50. It recognizes it is a query for network. Now it will start searching for the API in the ORCA network library. It calls it and it gives you the results back. Here you see, it has taken some time because of course there is a network delay, and these are GRS3 simulated SONiC switches. So they are not so performant. So here you have the table of the all VLANs. For example, I can perform some configuration options. For example, delete, delete. Ethernet 0 of VLAN, for example, 3 of device. Let us see what happens. It says success, and you can copy the previous command from the chat and paste it again just to confirm the results. I mean, these are the very basic configuration operations. You can literally write a paragraph. I want to do this in the whole network. So if there is an API available in the ORCA network library, it should be able to perform what user wanted. So the member is still in progress. So the member interface is gone. So this has happened on the device as well. So similarly, I mean, the APIs are available for BGP global configuration and MCLAC configuration. So these operations will work via ORCA as of today. But sometimes this is an open source, you can give it a try. Sometimes it might fail, like if you don't use a word device or you misspell something. That is a matter of training your model. So we are working on it. It's the current training is of, I believe, 200-300 lines of code in the JSON. That's it. That's a very, very minute data as far as it comes to LLM training. So more data we have, more training we have for our LLM, it will actually survive for the worst requests parsing as well. So this is about ORCA. Discovery, I mean, as I said, we use Neo4j database to store our topology. So once you have seeded the discovery with a single IP, it discovers the full topology. I will give you a glimpse only of it. The devices, for example, has been discovered here. They are connected, but no connection is being shown here. I will show you why. If you hover the mouse over one of the node of the Neo4j, on the right-hand side, you are able to find the configuration and properties of that specific node. For example, in this case, this node is a device node. So all the properties, the IP, management IP, the SONiC version, what it is running, all is being displayed. So actually, when we say devices are connected physically, it's not devices. These are interfaces. So it discovers the topology in that much detail. So from the Neo4j's this web console, you can click on this relation LLDP neighborhood. So now it says something more interesting. That is, some interfaces are connected to each other, and whom those interfaces are connected or belongs to. So you can double click on each and every, and now it will start revealing the secrets, how your topology is actually physically connected. So these violet colored nodes are my switches, and everything else is like, for example, this Ethernet of this device. Have a look at the relationship. This is a has relationship. So this device has this Ethernet 1, which is connected to Ethernet XYZ of another device. So this is in that detail. So for topology view, we do not have a separate UI as of now. We are using this Neo4j's web console, and this is giving you quite a detailed view as of now. But yes, we have plans to further develop a separate UI, which is more meaningful, filterable for the end user. Just to give you a Few more examples. For example, MC lag, I first configured using the ORCA APIs, MC lag, and then discovered it. So color coding is independent of the implementation of ORCA network library. It is chosen randomly by this interface. So as you see, this is a peer linking. And the brown color nodes are representing the port channel. Just hover the mouse over it, and on the right hand side, you will be able to find the configuration and the properties of that specific port channel. Just these are very basic configuration I just did for this demonstration. And what all is discovered, this is humongous data. Just double click on it and it will bombard in everything. So every Ethernet, every port channel, every VLAN, every port group has been discovered. And if you further expand these nodes, it will tell you, okay, how your network is connected. There are links between them. For example, if I hover over this relationship, this is peer linking. So from here to there is some peer linking MC-lag configuration has happened. So I think this is all from my side. If you have any questions, please let me know.